Hello, thank you for watching this video. So in this video, we're doing question 6 of May-June 2021 question paper mathematics paper 2. And the topic is the trigonometric functions, as you can see over here. So let's go. They are saying, in the diagram below, the graph of f and g are drawn for the interval from x is equal to minus 180 degrees to positive 180 degrees. A and B are points of intersections of both functions f and g. So we are given this function over here, and the orange function is f, as you can see over here. This function over here is f, and the purple function, this one, is g. That's what we're told. So we are given these two functions. Here's your f is the orange function, and g is the purple function. So both of these functions are plotted from minus 180 degrees to positive 180 degrees. They're saying A and B are the point of intersections of the two functions. So at this point we have A, and over there we have B. So these are the 2 points of intersections of the two functions. No problem. They are saying in 6.1, without using a calculator, determine the values of x for which f of x equals g of x on this interval from minus 180 degrees to positive 180 degrees. So they want us to find the values of x where f of x equals g of x. So you're looking for the point of intersections of these two functions, right? That's what you're looking for. You're looking for the point of intersections of these two functions. So they want the values of x. This is 6.1, right? They want the values of x where your f of x equals g of x without using a calculator. Your f of x is cos 2x, right? Is cos 2x, and your g of x is negative sine x. So they want the values of x such that these two things are equal. So you're looking for the point of intersection, but they do not want us to use the calculator. So in that case, what do? We know that this is a compound, actually it's a double angle identity, right? It is a double angle identity. So what you have, you know that if you have cosine of 2x, it has three identities. It can be cos squared x minus 1, or 2 cos squared x minus 1, or cos squared x minus sine squared x, or it can be 1 minus 2 sine squared of x. Could be any of the three, right? No problem. So what do? Between those three, which one do we choose? The one that we choose, we're going to put it here, but it should be related to sine, right? So it makes sense to take the last one, the one that contains a sine, because you know that you are just dealing with the sines only. So in that case, what do we have? Here, you will have 1 minus 2 sine squared of x is equal to negative sine x, right? So your 0 is equal to 2 sine squared x. 2 sine squared x minus sine x minus 1, right? Then we can factorize this equals 0. So we can say 2 sine x, and sine x here, 1 and 1. Which one will be negative, which one will be positive? Okay, so it's 2 sine x, 1 sine x, 1. So this one will be negative and this one will be positive, right? So it's a plus here and it's a minus here. That is what we have, right? So in any case, let's continue. So what you have 2 brackets multiplying each other, and the answer is 0, which means either this bracket is 0, so your 2 sine x plus 1 is 0, or your sine x minus 1 equals 0. So let's start with the easy one, right? So in this case, say, okay, sine, so your x is equal to arc sine. Oh, okay, we first solve for sine x here. or let's sign both sides actually. So your sine x here is equal to -1/2, and your sine x here is equal to 1. In that case, what we have is your sine x equals 1, right? So which is your angle x is equal to arc sine of 1, which is equal to 90 degrees. So the solutions will be on the first and second quadrant. So the first one will be x equal to 90 degrees, and for the first quadrant. In the second quadrant, it will be what? It will be x is equal to 180 degrees minus 90, which is also 90 degrees. So they're saying the point of intersection of these two positions is at 90. But if you look at 90, I would think it's this one over here. I think this is 90. So the solution that you have there is this one over here. We're done here. Then we'll move to this one over here. So what do we do? So we get that they say without using a calculator, right? So in this case, you need to be familiar with this special angle triangle, right? Where it's 2, 2, and 2, right? And then this is the midpoint. So this is 1 unit and this is 1 unit. This is 60, 60, say 30 here and 30 there. So this is square root of 3 over here, right? So you know that if you're looking at sine of 60 degrees, the opposite side, which is root 3 over 2, and the sine of 30 degrees, 30 is opposite, which is 1 over 2. That's what we have, right? This is 1 over 2. No problem. So if you're looking here, you have found that the sine of x is equal to a -1/2. You can see that a sine of 30 degrees is equal to that, right? A sine of 30 degrees is equal to that. So what you need to find, you need to go and find a reference angle now, which will be arc sine of 1 over 2, right? Your reference angle, arc sine 1 over 2. Actually, we can just say let's not even go with the reference angles and stuff. Let's just do this. You can just say, okay, this will be your arc, your x is equal to arc sine minus half, which is equal to minus 30, right? So if you look at this, b minus, it looks like your b here is minus 30, right? No problem. And then we're missing that one over here. So this is the fourth quadrant, right? So let's go to the second quadrant. So on the second quadrant, we're going to say, okay, our x is equal to what? Second quadrant, right? Second quadrant. Our x is equal to minus 180. What is this? We're going to this quadrant over here. Yeah, this is the second quadrant, right? This is the second quadrant. So in that case, it will be your x is equal to minus 180 degrees, right? Minus negative 30 degrees, which is this. So this will come out to be 150. negative 150. So I'll think this angle here is minus 150 degrees. That's what I have. That is what I have. Why? Because look, this is 0, negative 90, negative 180, negative 270, negative 360. So this is negative 90 plus x. This is minus 90 minus x. This is minus 180 plus x. This is minus 180 minus x. So our x in this case is that. So yeah. So the point of intersection, they intersect at A and B, which are those, right? No problem. So we're done with this 6.1. So I'm going to clean the board because I've entered 90, this and that. I'm going to clean the board and then we're going to do 6.2. So let's clean the entire board, all of 6.1, and we do 6.2. Okay, so now we're doing 6.2. 6.2, they're saying use the graphs above to answer the following questions. So at 6.2.1, how many degrees apart are A and B from each other? So they want to know how many degrees apart are A and B above each other. So they want apart from each other. So they want the horizontal distance there. So they're asking how many degrees apart are A and B are. How many degrees apart are A and B are from each other. So which means we're looking at the horizontal distance here, which is how to find it. You say the big X value minus the small x value. So in this case, we want the horizontal distance AB, which is equal to the big X value, which is the X coordinate of B minus the X coordinate of A. Right? No problem. So your horizontal distance is equal to, what is the X coordinate of B? It's minus 30 minus the X coordinate of A, which is minus 150 degrees. So you're looking at 120 degrees apart. So these two things are 120 degrees apart. So let's go to 6.2.2. What are they saying in 6.2.2? They're asking for which values of x in the given interval will f prime, or will the product of f prime and g prime be greater than 0? So they're asking which values of x where g prime of x times f prime of x are greater than 0. So they want you to find the values of x for which the product of these two things is greater than these things, is greater than 0. So you need to remember your calculus here. Now the question is, what does h prime or g prime or g prime or h prime represent? So these two things, they all represent gradients, right? So they represent your gradient. They all represent the gradients, right? Because this is a gradient of function g, gradient of function f, the gradient of function h, right? Fine. So you want to multiply two gradients, right? Such that the product of those two gradients is positive. If you're multiplying two things and their product is positive, what does that mean? It's either they are both positive or both negatives, because in order to achieve a positive, it should be a minus times a minus. They should give you a positive, and a positive times another positive also gives you a positive. So you're multiplying two gradients, right? And the product of those two gradients is positive. So that means you want the values of x where both of these two functions have positive gradients, or where both of these two functions have negative gradients. That's what you want. You want where the gradients are either both positive or both negative. How do you say that? when your function is increasing, the gradient is positive, right? Because if you look at a straight line like this, you say it has a positive gradient. This one has a negative gradient. So gradient here is positive and the gradient here is negative. This function is increasing and this one is decreasing. So you use the similar logic. So let's look at these functions here. Let's start with the purple one. You can see from here to there, this is a turning point, this is another turning point. So you can see from here, it's increasing here. So if it is increasing, this is the gradient at each and every point on that on this part. So the gradient in each and every point there, it will be positive. But look here, it's going down. So if it's going down, it has a shape similar to this. So the gradient is negative here, as you can see. So after the turning point, it's positive. That's how it is. So if you're looking now at this one over here. Now, looking at it, look, this one is going down here. So the gradient is negative here on the orange function. And it's positive here because it's going up. It's negative here again. It's positive up here. So you want where the product of their gradients is positive, and you will obtain it where they are both increasing or both decreasing, or both decreasing or both increasing. Because if these are gradients, they are both negative, which is both functions are decreasing at the same time, and here they're both increasing at the same time. So you need to go and look at your function. Where are these two functions both increasing and where they're both decreasing? So in this case, you can see here it's decreasing here all the way. Look here, it's increasing all the way. You don't want that, because if you multiply this negative with the positive, they will be negative. Look here, it's decreasing, right, all the way. Look here, it's increasing all the way, right? But look now, after here it's decreasing this orange function, and so is this one. So both of them after 0 and before 90, they're both decreasing. So in this interval between 0 and 90, they're both decreasing. So if you multiply the signs of those gradients, they will be positive because you will have this situation. So this function is increasing when? It's increasing for x is on this interval as 0 to 90. They're both decreasing there. Look, they're both decreasing. And look, after 90, both of them are increasing, which means you have this situation. So both of their gradients are positive there. So in that case, you say this or x an element of 90 to 270 degrees. So on this interval, both of these functions are increasing or both decreasing. So their product will be positive. So we're done with 6.2.1. So let's go to the next one, which is 6.2.2. What do we do? They are saying now, use the graph above to determine for which values of x, or we're done with this. So at 6.2.3, they are saying, determine the values of k for which this thing have no solution. Okay, so you are given this thing here. They want the values of k where cos of 2x plus 3, right? Cos of 2x plus 3 is equal to k. Have no solution. They want the values of k so that this equation here doesn't have a solution. Right? No problem. So, if you're looking at this, you can say, okay, let's take this to the other side. So what you have cos 2x is equal to k minus 3. What is cos 2x? Cos 2x is this function here, f of x. So what you have is f of x is equal to k minus 3. If you look at f of x, f of x is the orange function, is this function over here. right? Is this function over here. Here is it. So this value up here, this function is 1, and the lower value there is minus 1. You should know that by now, because the amplitude is 1. So if you have 1 here, which means the amplitude is 1, that is provided that the function is not vertically shifted, of course. So, you know, if you look at the orange function, it is defined between 1 and minus 1, which means the range of this function, the range of the function is this. Your range of your function f is y as an element of minus 1 to 1. What is the range? The range is the set of y values that your function uses. So this function uses the y values that are between minus 1 and 1. So for those y values that are between minus 1 and 1, for the y values that are between minus 1 and 1, this equation will always have solution, which is your f of x will always have solutions. Right? I'm saying for values that are between minus 1 and 1, this f of x will always have solutions. Right? No problem. Which means as long as this value that is here is between 1 and minus 1, your f of x will always have solutions. Which is this equation will always have solutions. But in this case, which means if you're looking on a timeline like this, for your f, this is a timeline for f. So timeline for f is defined from, will have solutions from minus 1, actually. Say minus 1 to 1. So for all the values that are here on this interval, all the values, including the endpoints, this is where your f will have the solutions. But for the values that are outside there, for the values that are outside that interval, now this will not have solutions. So this equation, which is equivalent to this one or this, will not have solutions for values that are there. So which means if this value of yours that you have here is more than 1, which actually is more than 1, it's on the left hand side of this interval, now you will not have solutions. Which means if your k minus 3 is greater than 1, you won't have solution. Which means for your k values that are greater than 4, you won't have solutions. And at the same time, if your k values that are less than minus 1, if your k, if this part here, which is your k minus 3, if it's less than minus 1, still, which means your k will be less than 2. Which means if your k values are more than 4, or your k values are less than 2, you will not have solutions. Which is, this equation will not have solutions. Because you know this equation have solutions for y values that are here. But anything outside this range will not have solutions. That's how I saw it. So I think they should be, your k should be greater than 4, your k should be less than 2. That's how I would have done it. So I'm done with this question, and I hope it does make sense to you as it does to me. Thank you for watching. So we're going to go to the next question, which is question 7. Last question of trigonometry, and then we're going to do Euclidean geometry. So let's go.